Practical Machine Learning with Python. Module 5, Clustering Results Metrics, offered by Stanford Crowd Course Initiative. The learning goals of the module are presented here. Need of evaluation of clustering results, internal and external evaluation, validity in internal evaluation, indexes used in internal evaluation, external evaluation and benchmarks, and indexes used in an external evaluation. Definitions of evaluation and assessment. Evaluation of clustering results sometimes is referred to as cluster validation. How to measure the similarity between two clusterings? We'll see soon. There are two categories of clustering evaluation methods, and the choice depends on whether a ground truth is available. The first category is the extrinsic or external methods, which require the existence of a ground truth, and the other category is the intrinsic, internal methods. In general, extrinsic methods try to assign a score to a clustering, given the ground truth, whereas intrinsic methods evaluate clusterings by examining how well the clusters are separated and how compact they are. When using an internal quality measure, make sure that it is independent of the algorithms. For example, Cummins optimizes such a measure and will always come out best when evaluating with respect to this measure. Validity is measured by an index that depends on the kind of structure that exists in the dataset. For example, Cummins clustering can only find convex clusters, and many evaluation indexes assume convex clusters. On a dataset with non-convex clusters, neither the use of Cummins nor of an evaluation criterion that assumes convexity is sound. Since algorithms that produce clusters with low intercluster distances, high intra-cluster similarity, and high intercluster distances, low intercluster similarity, we have a low Davis-Baldwin index. The clustering algorithm that produces a collection of clusters with the smallest Davis-Baldwin index is considered the best algorithm based on this criterion. As we have seen in a previous module, the intercluster distance dig between two clusters may be any number of distance measures, such as the distance between the centroids of the clusters. Similarly, the intra-cluster distance d prima k may be measured in a variety of ways, such as the maximal distance between any pair of elements in cluster K. Since internal criterions seek clusters with high intercluster similarity and low intercluster similarity, algorithms that produce clusters with high DON index are more desirable. About external evaluation, these types of evaluation methods measure how close the clustering is to the predetermined benchmark classes. However, It has recently been discussed whether this is adequate for real data or only on synthetic data sets with a factual ground truth. Since classes can contain internal structure, the attributes present may not allow separation of clusters, and the classes may contain anomalies. Additionally, from a knowledge discovery point of view, the reproduction of known knowledge may not necessarily be in the intended result. In the special scenario of constrained clustering, with meta-information such as class labels is used already in the clustering process, the holdout of information for evaluation purposes is non-trivial. One can also view the rand index as a measure of the percentage of correct decisions made by the algorithm. One issue with the rand index is that the false positives and false negatives are equally weighted. This may be an undesirable characteristic for some clustering applications. The F-measure, in the next slide, addresses this concern, as does the chance-corrected adjust a rand index. Notice that when beta equals to 0, F0 equals to P. In other words, recall has no impact on the F-measure when beta is equal to 0, and increasing beta allocates an increasing amount of weight to recall in the final F-measure. Jaccard index, this is simply the number of unique elements common to both sets divided by the total number of unique elements in both sets. The FM index is the geometric mean of the precision and recall P and R, while the F-measure is a harmonic mean. Moreover, precision and recall are also known as Wallace indices B1 and B2. There are the others external evaluation measures such as mutual information and confusion matrix introduced in this slide.